Hey guys, we are moving forward where we're going to talk about graphing rational functions. And in order to know about graphing rational functions, we are going to look at the parent graph of a rational function, which is f of x equals 1 over x. And this is called our reciprocal function. Okay, so let's talk about the shape of the parent function f of x equals 1 over x. If you look at the shape of this function, it creates what's called a hyperbola, where you have two curves in quadrants 1 and 3, and the graph is kind of moving very closely to the x and y axis on both curves, hugging it, but it doesn't cross over. So that's why our domain and our range is all real numbers, except x and y cannot equal 0. All right. The reason why this happens is because the graph, when you graph this function, it creates what's called a horizontal asymptote. So let's look at where our horizontal asymptote is. Notice if you look horizontally, okay, so we're looking, it's right at the x-axis. And the reason why this happens is because as x gets bigger and bigger and bigger and bigger and bigger, it becomes a larger and larger number, we're dividing 1 by a larger and larger amount, which means y becomes increasingly smaller, okay? So as x becomes bigger, y gets increasingly smaller. So that's why, as we look at this, it kind of gets closer and closer and closer and closer and closer to the x-axis as x gets bigger. Same with the negative values, it gets closer and closer and closer because we're drawing that number down to 0, close to 0. Now, if we talk about the vertical asymptote, look at it up and down. This graph can never cross over, and that's because if we look at when x is 0, okay, if we look at that, notice that that would make the function undefined. So our vertical asymptote is when the function would be undefined for the domain value. All right, let's move on. We're going to talk about some of the transformations for this parent function. Okay, so if I look at the standard form of a reciprocal function, just like we have standard form for absolute values and our quadratics, our standard form for a reciprocal function is a over x minus h plus k. Okay, we're going to talk about what each one does. H is going to be the horizontal shift in the graph, and it's going to shift, if it's positive, it's going to shift the graph to the left. If it's negative, it's going to shift the graph to the right. So we have that same thing happening with our h value. Whenever we're adding or subtracting to the x value, it does the opposite of what we would think. Okay, so our positive values make it go to the left, negative go to the right. K is the vertical shift. It shifts the graph up and down. Understand that we're actually having that shift to the asymptotes. So we can determine what the asymptotes are with our horizontal and vertical shifts. Now look at this. This K, or this vertical shift, is added to the entire function. Just like if we think back to our quadratic function, and again, it makes sense that it's going to shift the graph up or down along the y-axis. Now, our change in the h is going to, again, determine where our vertical asymptote is, which makes sense because we're talking about when x is undefined, right? The domain is undefined. Our change in the k, we can look and see where our horizontal asymptote is. All right. Now, if a is negative, the function is going to be reflected across the x-axis. all right? And if a is greater than 1, we'll have our vertical stretch, and if a is between 0 and 1, we'll have a vertical compression. Okay, so a lot is similar to our standard form for the other functions that we dealt with, which is our absolute values and quadratics. As I said earlier, your vertical asymptote is going to be determined by your h value when x is going to equal h, and your horizontal asymptote is going to be determined by your k value. Okay, y is going to equal k. Okay, so let's go ahead and write out our standard form of a function f of x equals a over x minus h plus k. Let's look at the transformations that they give us, and let's see if we can write the functions. So let's look at number 1. The reciprocal parent function is reflected across the x-axis. So if I think about my a value, okay, I know that my a value has to be a negative number. Okay, so I'm just going to put a negative there. Okay, it is translated 4 units to the right. Well, if I think about my right and left movement, what controls the right and left movement is my h value. Okay, if I am going to the right, that means h also has to be negative. It has to be a negative 4, right? And it goes down k units. Well, my k is also negative, right? It is my up and down shift, and it has to be a negative 3. Now I'm going to write an equation to represent the function, and then I need to identify the asymptotes. So I'm going to look at my standard form, okay? I know f of x has to equal a. A is negative. It's just negative 1 because we don't change, we don't stretch or shrink the graph, right? So a is just negative 1. So I got a negative 1 over x. My k is negative 4, so x minus 4 plus, or I'm sorry, my h is negative 4 minus 3, which is my k. I just go ahead and substitute. Now, if I got to think about my asymptotes, first I'm going to talk about my horizontal asymptote. Remember, my horizontal asymptote is determined by my k value. Okay, so how far the graph is shifted up and down. Okay, so I know that is negative 3. So I know my horizontal asymptote is at y equals negative 3. Okay, and I'm just going to put HA. And my vertical asymptote is determined by my h value. My h value is negative 4, so my vertical asymptote is at x equals 4. And be careful with your sign, okay? Be careful with your sign here, because remember that I know that h is negative, okay? I know h is going to be negative, but remember it does the opposite effect, right? It pushes the graph to the right. So I'm just grabbing that h value, okay? I know my sign is negative on h, but remember the opposite effect happens. So I know my vertical asymptote is at positive 4, not negative 4. All right, guys, I want you to take a second, look at the transformations, pause the video, look at the transformations, figure out what your A, H, and K is, and write those transformations. Go ahead and pause the video. All right, how did you do? If I look at the number 2, and I look at the information that they give us, I can tell that A has to be 2, K is 7, H is positive 4. So when I write my function, I have f of x equals 2 or I'm sorry, h is not positive 4. That is a mistake. H is positive 1. So when I write my function, I have f of x equals 2 over x plus 1 plus 7. All right. My horizontal asymptote is at y equals 7, and my vertical asymptote is at x equals negative 1. All right, if I go down and I look at number 3, they gave us the vertical and horizontal asymptote. And again, the key here is looking at that vertical asymptote, knowing that, again, you have the opposite effect with that h value. So if I know my vertical asymptote is at x equals negative 2, then I know my h value is going to be positive. Remember, it does the opposite effect, okay? K value, it moves the graph up 5, so that means that my k has to be at 5. So when I write the function f of x equals 1 over x plus 2 plus 5, all right? Big thing is just paying attention to your h value, making sure that it's that opposite effect. All right, guys, we're going to move on. And what I want you to do as we do this is I want you to graph this using your graphing calculator or Desmos as assistants. But how you're going to go about graphing this graph is you're first going to start with determining where your vertical and horizontal asymptote would be based on the changes of the graph. If I look at this graph, if I talk about my vertical asymptote, remember my vertical asymptote is determined by the h value. If I look, I notice there's no h value in number 4. So if h is equal to 0, I know my vertical asymptote has to be at x equals 0. Okay, x equals 0. Another quick way to check is just to look at the denominator and think, what would make the denominator equal 0? Well, if we plugged in a 0 for x, right? So I know my vertical asymptote is at x equals 0. Now, if I look at my horizontal asymptote, I know that is the k value. Okay, well, in this case, k is equal to negative 2. So I know my horizontal asymptote happens when y equals negative 2. Okay, so I would start sketching this graph by drawing, as I did over here, my horizontal and vertical asymptotes. And I'm going to do that by drawing a dotted line. My vertical asymptote is happening at when y is at negative 2, so I know it's a horizontal line at negative 2. And then I have another one that happens right at the y-axis, okay? That's my vertical asymptote, okay? So I'm going to draw a line, a dotted line, to represent my horizontal and vertical asymptote. I know that the graph is going to be two hyperbolas, okay? And I just pay attention to the shifts, right? This graph, the hyperbolas happen in quadrant 1, and it happens in quadrant 3 on the reciprocal function. Essentially, the only thing we did is we took the parent graph and we shifted it to the left 2 units. So that means that these hyperbola is just going to hug its asymptotes in the same quadrants. So I can go ahead and sketch the hyperbolas in both of those quadrants. Now, if I want to get a picture of this, okay, I'm going to, of course, pull out my graphing calculator to get a picture and just make sure my sketch is spot on. Let's talk about domain and range. If I look at the graph, I know that the domain is going to include everything, right? But I notice I have an exclusion when x equals 0. So when I draw my domain, you're going to put your bracket x, a line, and you'll just say, hey, it's all reals. We're basically saying this is all reals except x can't equal 0. x cannot equal 0, okay? Same for my range. My range is going to be all reals except y can't equal 0, okay? And if I put this in interval notation, you guys would do your all reals and then you would put your exception. Okay, so for instance, I would say y cannot equal 0. All right, no need to put the unions. All right, no need to write union, 0, all reals. We're not going to do that for this. Okay, so just you could put all reals and then you can put your exception. With that being the case, guys, I want you to move on to the next one. I want you to take time and I want you to determine your horizontal, vertical asymptotes, the different changes, and then I want you to determine domain and range. So identify your A, H, and your K, and then identify what the change is going to be to the domain and the range and what your vertical and horizontal asymptote is. You have 3 problems. I want you to go through that and work through that independently.